Hello everyone. Okay, please relax first while I sort something out. Okay, mic test, mic test. Okay, if you haven't downloaded the notes, please come here to download it first. Okay, mic test, mic test. Alright. Okay, thank you all for being patient. Okay, welcome to today's Facebook Live on rate. So the reason for shifting this week's Facebook Live to Friday is because not everyone, most of us were resting on Wednesday. So today is Friday. I'd like to give a shout out to all those people who were working to keep the entire economy moving on Labor Day. This includes our bus drivers, nurses, police officers, firefighters, and many other vocations such as hawkers as well. Okay? It's because of them we are able to enjoy that Labor Day and have rest. Right? So a little bit about myself. I graduated from NTU with a degree in mathematics and economics, and I've been teaching here in Maths Heuristics since 2011. So my main vocation here is the curriculum specialist. This includes looking through the worksheets, refining the worksheets, and improving upon delivery methods. But especially now, it's not so much of the technical for myself, although I do agree that some points that I can further improve. The main thing for myself now is how to improve delivery with these new technologies coming up. Okay, so I've been involved with a few projects, but I won't talk about them today. Right, let me just talk a bit about the Mastering Heuristics series, which my boss and mentor, Mr. Sunny Tan, wrote back in 2012. So for this book itself, you can see that it was published back in 2012, and this book is on the unit transfer method for speed and rate. So you can see here the contents of the book. there are two main components to it. One is for speed, one is for rate. And of course, today I'll be talking more about rate specifically for work done. Alright. So, right, to give you a better view of the contents of this book, this is what is covered in the book. Okay, in particular, we'll be covering rate of work done. Oh, it's over here. Okay. So let's get into it. Okay, the first thing I need to talk about, to establish about rate is this. First and foremost, in any rate problem that you do, you must always make time the same first. This is something you have to do regardless of situation, because without having time to be the same, without having time being the same, it's you are not able to make a fair comparison. So let me just give you an example here that I created. Let's say you are able to clear in 2 days 5 projects. Okay, so your colleague who's also fighting for that same promotion as you, in 3 days he can clear 6 projects. And then your boss wants to promote your colleague because he cleared more projects than you. Then do you think this is fair or not? Okay, hang on. I'll get to the first example very soon. Let me just establish a few background knowledge that everyone needs to know first. No, not fair. Why? Okay. Yeah, it won't be fair because first of all, the time taken is different. And if you actually make time the same, so let's say that the lowest common multiple between 2 and 3 is 6. We get them to the first common multiple, which is 6 days. So assuming your rate of work, your rate of productivity is still, your productivity is still fixed throughout, you would be able to clear 15 projects in 6 days. Whereas if your colleague works for 6 days straight with that same productivity, he would only be able to clear 12 projects. Okay, so if we look at the number of projects alone, in fact, you are actually 25% faster than him in terms of your rate of work or your productivity. So actually, you should be the one getting the promotion. Okay, this is considering pure work done, not considering other office politics stuff and all that. Okay, so this is the main idea, why you should make time the same, in order to have a fair comparison. Maybe I shouldn't have used pink. Should have used something else. Okay, but never mind. Okay. Yeah, correct. So this is one way you can argue with your boss. Okay. This is how I always argue with my boss also. So anyway, let's go on to guided example 1. With that established, let us see how we can use that principle to solve all these types of problems. Now, Leon can paint a room in 6 hours. Benson can paint the same room in 3 hours. how long will it take both of them to paint the same room together? So over here, let's list out all the information first. We have Leon, the number of hours, or rather the time in hours. And the number of rooms painted. Okay, for Leon, he can, in 6 hours, he can paint 1 room. Okay, and for Benson, in 3 hours, he can paint 1 room. So in order for them to paint the same room together, we have to consider how much they paint in 6 hours. So over here, you can make time the same. One of it is to reduce this down to 1. It can be done this way also. But when you do that, you always end up with fractions. So what we want to do instead is to work with whole numbers first, as far as we can. And we say that the lowest common multiple between 6 and 3 will be 6. So in order to get this to 6, if your time, okay, for this period of time he can paint 1 room, then when he doubles the amount of time that he puts in, the number of rooms that he would be able to paint will be doubled as well. So when we have this, and both of them are to work together, if we have both Leon and Benson working together, what's going to happen? So here is one confusion alert I want to point out. So what some students think will happen is that this should be 6 plus 6. No, they are working together in parallel time. So in that same 6 hours that they are working together, Leon will be painting 1 room and Benson will be painting 2 rooms. So the total amount of rooms that they will be painting in 6 hours will be 3. Correct? Now if this is the case, I want to find out how long it will take both of them to paint the same room together. So to do this, to get there, I need to have 1 room. If it takes me 6 hours to paint 3 rooms, if I want to divide this number of rooms by 3 to get to 1, my time taken should also be divided by 3. So when we do this, this becomes 2 hours. And you can see that the answer here must be 2 hours. Okay? Did I get promoted? That's a secret. I should be promoted. Yeah, it's 2 hours. Okay, so you have to make time common first. Okay, let me just keep emphasizing on this for those of you who came in after the introduction. You want to make time the same first. In order to have a fair comparison. Alright, if you got it, please spam the like button. Okay, Ryan, if you don't understand, please clarify which part you don't understand. Okay, very good. Oh, my big head is blocking. Let me move this down a bit. Okay. Very good, thank you. Now let's go on to number 2. Linda and Bernard took 3 days to complete a project. So Linda can complete the project alone in 7 days. How long will it take for Bernard to complete the project alone? Now let's look at it this way. You have Linda, the amount of time that she takes to do something, to do one project in days. Okay, my guess is that some of you don't understand what I'm doing about the project. So let me just briefly explain first. Now, Linda and Bernard took 3 days to complete the project. So this means that in 3 days, they can clear one entire project. You will see that the details of this project is not known. Okay, we do not know exactly how it's split, but we just measure the progress of the project as one whole, where one whole represents the completion of the project. So if it's something like 1/3 done or half done, it means that it's not, this represents the fraction of the progress of that project. Okay, represents the progress of the project. Okay, so that is what the fraction and numbers represent. Maybe I should just be more specific here. Project progress. So now Linda alone needs 7 days to clear one project. Okay, why is it not 6 plus 6? Because they are both working in parallel. Okay, let me just show it to you in this example too. Okay, so now in order for us to make a fair comparison, we have to make time the same first. So let's do that. Between 3 and 7, that lowest common multiple is 21. So to get to 21, this entire row needs to be multiplied by 7, and this entire row needs to be multiplied by 3. So this becomes 7, this becomes 3. Okay, so imagine this. Why is it not 6 plus 6? Now you just imagine that this is day 1 to day 21. Okay, and let's just for simplicity say that this is the 1st of March and this is the 21st of March. So the time will flow for both of them, for Linda and Bernard. It will flow for both of them. Both of them are working parallel together in time. Okay? From the 1st of May to the 21st of May. Okay, let's just imagine this, something more concrete for you to be able to understand and grasp the concept. So once we have this ready, in order to find B alone, we can say that in the 21 days that they were working together, B will be clearing 7 minus 3 to give us 4. B would have finished 4 projects on its own in 21 days. So in one day, not in one day, you want to find out how long would it take for Bernard to complete the project alone. Notice the keyword here that they emphasize on is the project alone, which means that they only want one project. So to get one project, for him to clear 4 projects, he needs 21 days. Then we divide the project progress by 4 in order to obtain one whole project. When we do this, this entire 21 days gets divided by 4 as well. So this becomes 5.25. Okay? So then we can say that the number of days that he needs must be 5.25 days. Okay, if there's no restriction on this, you can leave it in decimal or fractions. Either way is fine. Yes, 5.25 days. This is the question already. The one, can I scroll down a bit? Okay, let me zoom out a bit. Okay. Yeah, 5.25. Okay, there's some argument that there shouldn't be a decimal or a fraction for days. But if you come to think of it, it's possible that way. In this case, it will simply mean 5 whole days that they have been working and 1/4 of the time that they were working, of the ordinary time. Okay, because if you think of it, the day itself can be partitioned into several periods. Okay, if you got it, please spam the like button. Yeah, final answer, yes. For final answer, it's you need to write your units of measure, because your 5.25 could be hours, could be seconds, could be something else, right? Okay, very good. Alright, let's move on to number 3. Okay, so over here you see that there are 4 people: Ben, Harry, Ken, and Mandy. Okay, Amanda, which part do you not get? You let me know first, then I'll address it later on. Okay, so now let's list out what we have. When Ben partners Harry. Okay, how much time do they take to do something? The time in days, and how much of the project progress do they complete? Ben partners Harry, they take 24 days to clear one project. Between Ken and Ben, okay, try to align them vertically first. Try to put things vertically to one another so that you can organize your information more clearly. For Ken and Ben, they take 8 days to complete one project, the same project, which is one whole. We use one whole to represent that project progress. Then when Harry partners Mandy, they take 12 days. Wait, sorry. Okay, leave a little gap first. So when Harry partners Mandy, they take 12 days to clear one project. Right, so now between all these 3 numbers, remember we want to find out how many days does Ken and Mandy take to complete the project if they work together. You want to find a way to get Ken and Mandy to be working together. So this is not that straightforward. But first things first, you want to make time common. For fair comparison. Okay, let me just put fairness for short. Make time the same for fairness. Let me just put fairness for short. Okay, so once we have all this ready, we look at 24, 8 and 12. What is the lowest common multiple between them? So if you're not too sure about this, just list out the first few multiples. You will see that the lowest common multiple between these 3 numbers is going to be 24. 24 is the... Yeah, correct. So if this is 24, you will see that there is no need for you to do anything to B and H. For K and B, you want to multiply this by 3 to get your time to 24. Your project progress will then be 3. Then for this, you want to multiply it by 2, you will get 24 and 2 projects done. Okay, once we've made time common already, everything else can be fairly compared. So now, we want to look for a way to find out. Yeah, the lowest common multiple is 24. We want to look for a way to find out how to isolate and obtain Ken and Mandy alone. So this part you need some creativity. First of all, I will combine the second row and the third row. And if I were to do this, I would obtain everyone. Correct? How was this obtained? I take row 2 plus, okay, maybe let me call this row 2, row 3, row 1. So row 2 plus row 3, by adding these two together, we can obtain everyone working together. So we can say that in that same 24 days that all of them are working together, they will be producing 3 plus 2, 5 projects. Okay? And then later on, take note of the objective. The objective here is only between Ken and Mandy. How do I obtain Ken and Mandy? The cruel part about maths is that when you want something, right, it indirectly implies that you do not want everything else that is not inside here, which means that you do not want B and H. Okay, you do not want B and H, you want to get rid of it. So we will take row 4. Okay, let's just call this row 4 for short. We take row 4 and minus off row 1. Then we would now say that in the 24 hours, in the 24 days, they would be doing 5 minus 1 to give you 4 projects. So K and M in 24 days is going to produce 4 projects. Okay? And finally, in order for us to obtain one project itself, we would have to divide this entire line by 4. 4 projects takes 24 days, so one project itself must take the project progress divided by 4, the time also divided by 4. So this would give us 6. Which means to say that A and M, Ken and Mandy, would take 6 days to finish this up. Okay? No, it's not 4 days. 4 is the project progress. But you want to find the number of days for Ken and Mandy working together to produce one project. That will have to be 6 days. Okay, very good. Okay, very good. Okay, if you got it, please spam the like button. If you understand what's going on here, please spam the like button. If you don't, please clarify. Like what I always emphasize, please clarify when in doubt. Okay, if you leave the doubt to accumulate, it will just become a giant snowball that will overrun you. Can't see the things that you write on top. Oh, okay. Okay, let me try to zoom out a bit first. Why add all together? Okay, the main idea for this is at the end of the day, you want to find your objective, which is Ken and Mandy. Correct? You want to find Ken and Mandy. So to do that, you need some creativity over here because you can't just get it directly by taking K and adding M together. So what we have to do is to look for a combination of steps to get rid of B and H together. Alright? That's the whole idea. Okay, very good. Why 5 minus 1? Because here we are removing B and H. We are removing off B and H so that we can obtain the amount of work that Ken and Mandy does in that 24 days. That's the reason. Okay? Okay, so let's move on to number 4. Now this is a popular type of problem. Okay, so let me just briefly, let me change the question a bit so that it's more clear for you who's listening. Okay, please change this one to Taylor's. And please change this one to Taylor's. Okay, the reason for this is because you see dressers, I have to make that emphasis, and even if I make that emphasis, you may not be able to hear it properly, because dressers versus dressers is going to be quite confusing for you. For me, I'm okay with it, but it's going to be quite confusing for you. So let's just change this a bit. Yeah, okay. Now there is a fundamental way to do this, and there is also a shortcut to do this. So let me just explain the shortcut because it's very much intertwined with the fundamentals. Alright, so in a sewing factory, 5 tailors can sew 10 dresses in 10 hours on average. How long will 50 tailors in the factory take to sew 50 dresses on average? So you see how that comes out. That comes out a lot more clearly. Right, so here you have to understand one thing first. There are factors of production, or what I would call inputs for short, and an output. Okay? Your inputs are basically labor and time. So in other systems, there are things like capital or machine. Let's just not go into that. For now, there are 2 inputs here, tailors and time. Okay? So the output is the product, which is the dresses. Okay, you have 2 inputs here, and when they combine each other, they give you a product of the dresses. So let's list out what we know. Here we are told that 5 tailors can sew 10 dresses in 10 hours. Alright? Alright, let's think of it this way. When you increase your input, what happens to your output? Does it increase or does it decrease? Okay, when you're not too sure about everything, try not to memorize a lot of things. Okay, we use reasoning to see what the outcome will be. If you have more tailors, if you have more time, would you be able to produce more or would you be able to produce less? It's definitely increase. Okay, so you want to reason it out this way, because it's not, I mean, for most people it's not possible to memorize every single thing. So when your inputs, similarly when your inputs decrease, your output will decrease. Okay, so what if you want to increase your output? If you want to increase output, you need to increase your inputs, and vice versa. If you want to decrease your output, you need to decrease your input. So it goes both ways, theoretically speaking. Okay. So now let's look at what we want. The objective here is that at the end of the day, you must have got 50 tailors, you must have 50 dressers. So let's just change one thing at a time first. Okay, let's say that at the end of the day, I need to have 50 tailors. Let me increase my input for the tailors first. Then I fix your time at 10. So you can see over here, the trick is you fix the time and change the tailors and dressers. Okay, we just change one thing at a time to analyze it. So if you increase your tailors by 10 times, what's going to happen to your number of dressers that you produce? You're also going to be able to produce 10 times more, as many dressers as compared to the original case. Correct? Then next, we see that you want to have 50 dressers only. Okay, at the end of the day, I only want 50 dressers. So in order for me to get 50 dressers, I have to decrease my number of dressers, right? And I need to divide the output by 2. Okay. Now let me fix the number of tailors as well, because this is in line with what I require. I need to have 50 tailors. So now I change my time only. When this happens, if you divide the output by 2, the amount of time taken, because you have fixed your tailors already, only the time can change now. Your time will be divided by 2 to give you 5. So this is actually your answer. You need 5 hours for them to sew this on average. Okay, yeah, very good. A lot of you got. Yeah, your idea is correct, Shiwen. Jessica, you got it. But don't you need to divide the tailors also by 2 if the others are divided by 2? No. You are fixing your number of tailors at 50. And you are only varying the time component. Okay, very good. Yep, sure increase. Okay, so that is the main reasoning for this. Okay, when in doubt, reason it out like this. Okay? Now you see, if let's say you have a certain number of tailors, you don't care about whether it's 50 or 100 or whatever. Let's just fix it at 50. When you change your dressers, when you divide this by 2, and your tailors is fixed, you can't change your tailors. What is the only input that you can change? That would have to be your time. When you change your time input, it has to be in line with this change over here. The change here is divided by 2, so must this be divided by 2. Okay? Do you need to change the output to fix the input? For this question, yes. We are changing the dressers to 50 so that we can get the time. Okay? So you can see that this step here, I fix my tailors. And I change the time and dressers in order to match my objective. Okay? Hey, if you don't understand, no worry, you can always view the replay. So many angry face. How about average? That is the time that they take on average to clear this amount. It's not always 10 hours. I mean, if you have a team of 5 people doing this type of production, it will not always be the case that it's exactly 10 hours in real life. Okay, I don't think it's possible. Okay, Amanda, which part do you not understand? Okay, don't worry, you can always watch the replay. If you want to clarify something, let's clarify it now. Okay, you got it, please spam the like button. Okay, Brudula, at the end of the day, you have to understand the fundamental principles. Then use the unit transfer method to organize your information and to solve it with speed and accuracy. Okay, the part where you divide by 4. Okay, let me go back to here. Okay, so for Amanda, the main reasoning why I divided this by 4. Okay, think of it this way. If one project takes you, okay, 4 projects takes you 24 days to do finish. And let's say that your rate of work is the same throughout. One project itself should take you how many days? You will want to divide this by 4 so that you obtain 6 days over here. Okay, that is the reasoning. If the question fixed the hours at 10 hours, how to solve? Then you just don't need to change the 10 hours. You don't need to change the 10 hours. Why is it divide by 2? Okay, let me ask you one thing. From 100 to get down to 50, you can only use multiplication or division. What would you multiply by or what would you divide by to obtain 50? Okay, that is the main thing. Okay, so I've come to the end of my presentation. Thank you all for having me. So this is from the book of the unit transfer method of speed and rate. So let me just make some announcements. For the June holiday programs, we have already come up with the timetable online. And thank you for the overwhelming response, because there are a few more parents who we haven't got back to. We will be getting back to them very soon on the inquiry for this. So this would be on the unit transfer method. Okay, where we will be covering about the topics on whole numbers, fractions, decimals, percentages, and ratio. The best part about this holiday program is that all these courses from P4 to P5 and P6, they all come with the total integrated